All right, so I think this is recording. Let's take a look at this problem number 5 on the parabolas. We know that this conic section is a parabola because it only has one variable that's being squared, the x. Y is not being squared. When x is being squared, we know that the parabola will either open upward or downward depending upon whether p is positive or negative. So let's attempt to rewrite this equation, get it in standard form, so that we can start answering these things that they want, the properties that they want um, about this parabola. I like to put my squared term on the left-hand side of the equation. So I'm going to add, well, hey, all these numbers are even, so let's start out by dividing everybody by 2. It'll just get the numbers smaller and easier to work with. All right, so I've got 4y plus 5, and I'm going to write this information on the other side. And I'm going to put my x squared term first. So negative 2 divided by positive 2 is a negative x squared, and then plus 6 x. Well, I like to have my leading coefficient of x squared being positive when I complete the square, when I try to factor it. So I'm going to change the sign of every term on both sides of the equation. I'm going to make this x squared minus 6x. I'm going to leave myself some room so I can complete the square. And then I'm going to turn this into negative 4y minus 5. All right, so I'm ready to complete the square. I look at the coefficient in front of this linear term, in front of the x to the first, and half of negative 6 is negative 3. But when I square negative 3, I get a positive 9. Purpose of doing that is so that now we can easily factor this to x minus 3 quantity squared, because that half of negative 6 was negative 3. To balance the equation, don't forget to add that 9 to the right-hand side. So we have negative 4y plus 4. We need this coefficient in front of y to be 1. Let's factor a negative 4 from each term. That'll change the sign. Negative 4 times a negative 1 is positive 4. So now that this is in standard form, we can identify the vertex. It's 3, 1. We can take 4p, set it equal to the coefficient in front of the linear term, and solve for p. Positive 4 times a negative 1 is negative 4. So since it was x squared, we knew that it opened upward or downward. And since p is negative, we know that this parabola is going to open downward. The crucial point on this parabola is the vertex. We know that vertex has coordinates of 3, 1. We also know that there's 2 lines of interest, the axis of symmetry that passes through the vertex, and it's referred to as the axis of symmetry because this parabola is symmetric about that line. There's another line that's perpendicular to this axis of symmetry that's called the directrix, and our parabola always opens away from the directrix. Your parabola will never intersect the directrix. Inside this parabola, I refer to it like as the bowl of the parabola. I don't know if that's mathematically correct, but it describes it in my mind. I want the coordinates of this focus. I know that this vertex is the midpoint between the point of intersection of my 2 lines and this focus. This line is x equals 3. It's vertical. It's never, a vertical line is always going to be x equals something. horizontal line is always going to be y equal to something. I'm 1 unit away from the vertex to be either at the focus or at the directrix. If I move 1 unit up and down is controlled by the y variable. So 1 plus 1 is 2. So this directrix has the equation y equals 2. If I move 2 units down, 1 minus 2 is a negative 1, and that'll give me the coordinates of this vertex. So we've answered everything that they want to know about this. We've rewritten the equation in standard form. We've identified the vertex. We found the value of P. From using that value of P and the symmetry of the problem, we found the equations for the two lines, the directrix, and the axis of symmetry, and we also found the coordinates of this point that they call the focus. So I hope that helps, and I'll talk to you later.